So first we would start off by plotting all of our points, kinda. So since the vertical shift is up 1, then there's 1. This is kind of the midline.
Oh my gosh, have you heard this song by Little Mosey called Burberry? It's so good.
Okay. And our amplitude is 2. So 1, 2. It's negative. -1. Wow. Okay. So then our increments would be pi over 4. So we would have something here, 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 and here, and one more because we do have a horizontal shift. So pi over 4, and then pi over 2, and then 3 pi over 4, and then pi, and then 5 pi over 4 would be our last point. So then the horizontal shift is over. So for sine, you would do midline, up, back to the midline, down, and then back to the midline. So for the cosecant graph, we have vertical asymptotes every time the original sine graph touches the midline. So we would end up having asymptotes here, here. I'll move this up a little. And there's one here. Okay, great. So then for the cosecant graph, it would be starting from the max of the sine graph. You would go up and have those little guys approach the asymptotes, and then you would go down and have those little guys approach the asymptotes too. Okay, so the domain of this function, so domain is talking about the points on the x-axis. So we would have all real numbers and an exclusion at wherever the asymptotes are, which would be, so the domain restrictions would be pi over 2k plus pi over 4. And the reason for that would be because our period is being divided by 2. So instead of the normal pi k, it would be pi over 2k, and then plus our horizontal shift. And for the range, it's going to be negative infinity to -1, bracket, union, another bracket to 2, and positive infinity, and a parenthesis.